Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is Exploration. Every week on Exploration, we discuss the fascinating world of science and its impact on society. And today, we're going to summarize some of the top stories in science and answer your email questions. You know, I get a lot of emails, and there's no way I can answer them one by one. So instead, I'm going to just simply answer blocks of emails that I get on air. And hopefully that'll satisfy the curiosity of those people that have been emailing me. One question concerns outer space. For example, an underground lake of liquid water found under the surface of Mars, of all places. Not to mention a space force. The Vice President of the United States came out with details stating that by 2020, the United States should militarize space, perhaps, by creating a space force. We'll talk about that. And then NASA also shot a probe to the sun. And some people say, well, why do that? If you want to look at the sun, you simply just go outside. So why bother to spend billions of dollars to send a probe to the sun? So we'll talk about why the sun is so important. And then we'll also answer some email questions. One question that I get persistently is that people say that, well, when they think about somebody, all of a sudden the phone rings, and there they are. Or you're thinking about somebody, and then you bump into them, and they say, well, gee, I was thinking about you, too. Now, what's the probability? The probability that you're thinking about somebody, and that person simply just calls you on the telephone at the exact same time. So we'll talk about synchronicity. And we'll say a few things about Mars. Some people still believe that there are evidence of an alien life form on Mars creating structures. And therefore, then the question is, well, why doesn't NASA talk about these things? We'll answer that on Exploration. And then there's a new book out that some people have mentioned. It's called The Big Bang in a Little Room. Is it possible that one day we can create a mini universe in our living room? Sounds outrageous, but yeah, physicists are working out the mathematics necessary to do that. And then the question is, well, if we can one day create a universe in an oven in our living room, then maybe that's how our universe was created, by a superhuman that cooked our universe in an oven. Well, let's talk about the physics behind that as well. Well, let's just now jump right into some of the top stories of the week and also questions that I get from you, the listener. Well, one set of email questions I get is about outer space. First of all, we recently sent a space probe to the sun. And some people say, well, what a waste of money. If you want to know something about the sun, you just look outside. Or use a telescope with filters. Why do we need to send a probe to the sun? Well, believe it or not, one of the least understood objects in the solar system is the sun. Because planets are relatively easy to analyze. We can send probes there. We can land on them, for God's sake. We can put orbiters around them to get detailed photographs. However, the sun, you cannot do any of the above. It is extremely dangerous getting close to the sun, and the sun constantly changes, and there are mysteries about the sun. For example, ice ages. During the Middle Age, there was a mini ice age. There are paintings during the Middle Ages which show that famous lakes were once frozen over solid. Now they're not. Now they're liquid. But yes, there are paintings showing that ice skaters would skate where there's no ice today. And so during the Little Ice Age, some people claim that maybe, just maybe, sunlight diminished. And can you prove it or disprove it? For that, we need to understand more about the sun. And then in 1859, there was a gigantic solar flare that was emitted by the sun. The solar flare was so huge that it created the northern lights over Cuba. That's right. You could read the evening newspaper in Cuba at night by the light of the northern lights, which by rights should be in the Arctic, not over Cuba and the Caribbean. Well, we physicists have worked backwards and calculated what would happen today if that Carrington event of 1859 were to happen today. Not just telegraph wires being blown out, but it would blow out our satellites. It would knock out power stations. It would create havoc with the space program. Think about that for a moment. If power stations are wiped out, it means refrigerators get wiped out, which means food riots within a few days, which means credit card transactions cannot be done because they're out, the internet is out, commerce comes to a halt because nobody can keep track of things. And we saw a preview of that recently in Times Square. There was a blackout in Times Square, and many people could not book hotel rooms because the credit cards were out. And as a consequence, with the credit card machines out, it meant that you couldn't book a room in Times Square, and people had to sleep in hotel lobbies. That's just the beginning of what could happen if there's a monster solar flare on the sun. And so that's why we want to know more about the sun. We actually have a lot of mysteries about the sun. Another mystery is, as you go away from the sun, things get hotter. That's right, things get hotter, not colder, as you move away from the sun and hit the coronosphere. Why is that? We don't know. And so the weather on the Earth is controlled by the sun. Global warming is influenced by the sun, but we really don't know the cycles of the sun that well. So once again, the mini ice age, what caused it? Or the Carrington event of 1859, could it happen again? We don't know. And so these are some of the reasons why we want to send a space probe to the sun. And speaking about space probes and the space, our space probes, the rovers, have sent back information about, well, evidence of water and water erosion on Mars. But now we have evidence of a lake of liquid water underneath the polar ice caps. This is amazing. It means that microbial life cannot be ruled out on Mars. Now, let me explain. Every time we look at pictures from the rovers, we see evidence of water erosion. We see the remnants of ancient riverbeds, ancient lakes, ancient oceans, but there's no water there. All the water is gone. But now, looking at the polar ice caps, a region that we don't understand very well at all on Mars, we find evidence of a lake of liquid water that is about a mile underneath the south pole of Mars, and it is 12 miles across. It's not a small lake at all. So this shocked the world of astronomy, realizing that Mars is much more interesting than we were led to believe. Now, why the excitement? Because where there's water, there could be life. You see, reporters say, follow the money. However, astronomers say, follow the water. Where there's water, there could be proteins, there could be amino acids, there could be DNA, and the chemicals of life are water-soluble. So meaning that a lake on Mars would be an ideal place to look for microbial life. Now, this lake is underground. It's not on the surface of Mars because Mars, for the most part, is frozen solid. And so it was rather a shock when they found liquid water. You see, Mars has plenty of water, but it's all ice. Mars is the frozen desert. It's solid rock. And so that's why it was quite a shock when scientists realized that liquid water can exist on the surface, under the surface of Mars, in a place where scientists never looked before, under the surface of Mars. Now, we're not talking about a Martian civilization. No, we're talking about the potential of microbial life being on Mars. Now, Mars lost its water over 3 billion years ago. Now, if by chance an advanced civilization were to somehow exist 3 billion years ago, where would it flee to? It would follow the water. It would go A, into outer space. That's where most of the water went. B, to the polar ice caps, because it probably snowed in the polar ice caps, freezing whatever water there was. Underground. Well, guess where we have not been? We have not been underground. We have not been to the polar ice caps. And that's where we expect alien life forms may have fled, assuming they existed 3 billion years ago. And that's why it's quite interesting that scientists found this lake. Now, don't get your hopes up, because the lake is probably made out of salt water. That's right. You see, as lakes contract with time, they dissolve more and more materials, including salt, and that's why we have the Great Salt Lake of Utah. The Great Salt Lake of Utah was once freshwater, but it began to shrink as the Ice Age ended, and shrinking caused it to absorb more and more salt chemicals, and that's why the Great Salt Lakes are quite salty. Same thing for Mars. So even though that lake was discovered of liquid water under the surface of the ice caps, chances are it's too salty for life. But hey, we don't know for sure. And speaking about outer space, I've been getting more emails concerning the Space Force. The Space Force is an entity being proposed by the President of the United States, a new branch of the military. A new branch, the newest since 1947, when the United States Air Force was created. Now, some people oppose it for obvious reasons. The United States Air Force, many of those officials are grumbling about it, because for them, it means losing an arm or losing a leg. Because where is the Space Force going to come from? It's going to come from the Air Force by taking whole chunks of the Air Force out and creating the Space Force. So they're naturally skeptical of the idea. But you see, there's another reason for caution. The Chinese have an expression, never pick up a rock, only to drop it on your own feet. In other words, don't gamble on things that could backfire in a big way. Now, it turns out that, well, who's the most vulnerable to a war in outer space? We are. Not the Russians, not the Chinese. Over half. Well over half the satellites that are operating in outer space are our satellites. So who stands to lose the most if a war breaks out in space? Well, you may say to yourself, can satellites defend themselves? Can satellites shield themselves? And the answer is no. Our satellites are sitting ducks. They're not shielded, they're not reinforced, and they don't have guards to shoo away any killer satellite. No, they're sitting ducks. If a war were to break out, we would be the big loser. Now, how would a war break out? The simplest way is to detonate an atomic bomb over Kansas. That would create a shock wave that would not only paralyze power plants on the Earth, it would also blind satellites in outer space. So just like two gunfighters squaring off, and one gunfighter throws sand in the eyes of the enemy, that could really change the whole calculus of the gunfight. North Korea, a small country, can detonate a bomb over Kansas, paralyze our satellites so we're blind, and then wipe out our power stations so we don't have the ability to create a functioning Air Force. Now, that's a worst-case scenario. But it just goes to show you that something bad could happen if war breaks out in space. So what do we do about it? Well, let me quote from none other than Ronald Reagan. Ronald Reagan had a two-pronged strategy dealing with the Russians. First, he created peace through strength as a motto. Second, not only did he build up the military, he also cut a deal with Gorbachev. You see, the president was no fool. He realized that if a war were to break out, we would suffer more than the Russians. And so he cut a deal to set the ground rules for an arms race and a war. That is, you cannot by treaties ban war, but you can regulate it. Make sure that it doesn't spiral out of control. Now we have the Outer Space Treaty of 1967, and it has tremendous holes in it, because after all, it was signed 50 years ago. It says, first of all, no nukes in space, but says nothing about non-nuclear weapons in space, like killer satellites, kinetic energy weapons, laser weapons, X-ray weapons. None of that included in the Outer Space Treaty. Second, it says that no one can claim a celestial body as their possession. In other words, you cannot claim the moon as a nation. However, now we have Elon Musk, Jeff Bezos, billionaires that are fully capable of landing on the moon and planting their flag on the moon. And so we need a new outer space treaty. We need a true treaty because the old one is so way out of date. 50 years out of date. And that's why we need a new outer space treaty to regulate, not necessarily ban or outlaw, but to regulate a possible confrontation in outer space. Because, as I said, who is the big loser if a war were to break out? We are. For example, one scenario is that an enemy nation gets a barrel, fills it with nails, and simply detonates it in outer space. Once you have a keg of nails, these nails scatter in all directions, wiping out your satellites, creating havoc. And that is even a non-nuclear way to disturb the heavens. So let's hope that we get a revised outer space treaty so that things don't spiral out of control, and they could very rapidly. And then, believe it or not, one letter that I get in emails persistently concerns synchronicity. So many people out there have thought about somebody, and then they call you on the phone. And the question is, what is the probability of that happening by accident? It must have been destiny. It was meant to be that you would talk to that person on the phone. Sometimes you think about somebody, they later call you, and both of you were thinking about each other. How can that be? Well, synchronicity is actually due to a quirk of the human brain. The brain remembers hits, forgets the misses. Because there's so many things happening, your brain will be cluttered by all this useless information, so it forgets the misses. But when a hit happens, it remembers, it stands out every time a hit is made. And that's how people talk to dead people on television. If you watch these psychics on television very carefully, you realize that most of the time these psychics are wrong, but you forget those misses. So it's like a fishing operation. The psychic asks you a lot of very innocuous questions until it gets a hit, and then pursues that hit again for another hit. And sooner or later, you say to yourself, the guy's a genius. He's a psychic. He talks to dead people. Look at that. It's amazing. How did he do that? Well, if you videotape it and play it back, then you begin to realize that your brain edited a lot of things, and that's why synchronicity exists. Another thing is people see faces on Mars persistently. Why is that? Well, when you look at the sky and you see the clouds, have you ever noticed that independent of your will, no matter how hard you try, you cannot help but see comic characters or Donald Duck or Mickey Mouse in the clouds? No matter how hard you try, you cannot prevent your brain from coming up with all sorts of cartoons and fanciful explanations for shapes in the cloud. Now, why is that? Because of evolution. You see, it's good for you if you see things that are not there, like the rustling of tree branches in the forest. Because 9 times out of 10, it's the wind. But 1 time out of 10, perhaps it was a predator waiting to jump on you, and it saved your butt. So that's why nature and evolution gave us the ability to see things that are not there. They're not there. It's our imagination. But a fraction of the time, it was there. There was a lion. There was a tiger hiding in the forest, and it saved our butt. And that's why it's actually a good thing for our evolution to see things which are not there. Because 9 times out of 10, it's not there, but you forget them. They're misses. But 1 time out of 10, it'll save your butt. So that's why we have something called synchronicity. Now, another question I get is a book came out recently called A Big Bang in a Little Room. Sounds crazy. It's by Azia Morali. She's a PhD in theoretical physics at Brown University, and she writes about cooking a universe in your living room. How is that possible? Well, it's not so outlandish as you might think. We have the Big Bang, and the Big Bang theory says that our universe is a bubble of some sort. The bubble exploded 13.8 billion years ago, and it's been expanding ever since. But now we have something called inflation, which says that the Big Bang was a quantum event, meaning that it could happen again, and again, and again. Big bangs can happen all the time. So our bubble can sprout baby bubbles. Baby bubbles, which are called baby bubbles and baby universes, or bubbles can collide, giving you a bubble bath of universes, with universes being born all the time, with big bangs happening all the time. Now think about that. If big bangs can take place because you can heat up a region of space and time so hot that it bursts out to create a baby bubble, then why can't you do that artificially? So, some physicists have done the calculation, among them Alan Guth of MIT, who I actually had on the air explaining this process. You heat a certain region of space and time to a very hot temperature, trillions upon trillions upon trillions of degrees, so hot that a hole opens up in the fabric of space and time. That hole is the beginning of a baby universe. Now, when the baby universe expands, it doesn't kill you because it expands outward. Just like a soap bubble will blow a baby bubble outward, not inward. And that's why a baby universe can be born without killing the parent universe. However, I should point out that Alan Guth on the air told me that even though it's not going to kill you, there is a backlash. The creation of the wormhole will be like an atomic bomb. And so you will definitely feel the shockwave and radiation from the creation of a baby universe. Now, the point I'm building up to is very simple. If it's possible that a super advanced person can create an oven sufficiently hot to open up a wormhole, which would create a baby universe from our universe, then maybe that's how our universe was created. In other words, the Bible talks about, well, the universe from nothing. Maybe that nothing was an oven cooked up by a superhuman with superpowers capable of heating up a parent universe hot enough to create a baby universe, which eventually became our universe. Now, of course, your mind gets spinning at this point, realizing, oh my God, was our universe created artificially? Was our universe created by another super being that we would identify with a God? Well, the question is, can you prove any of this? Well, that's where it gets a little tricky. Because our atom structures today, like the Large Hadron Collider, are not powerful enough to create a wormhole or a gateway to another universe. So at the present time, it's all theory. It's always nice to talk about theory, but it's still theory. So in other words, did God create the universe, or was the universe created artificially by a super being? Well, in my personal opinion, I think you cannot rule out all those ideas, because that's where physics ends. We simply don't know what happened before the Big Bang, and why it banged, and where did the bang come from. These are things which are still at the very cutting edge of our understanding of physics and science. However, the book is very interesting. The book is called A Big Bang in a Little Room, The Quest to Create New Universes. And the question is, was our universe an artificial creation of another super race? Well, I get another series of questions going back to Elon Musk. Elon Musk of Tesla Motors said that maybe we live in a simulation. Just like in the movie The Matrix, Keanu Reeves has a heart attack when he finds out that the world he lives in is a computer simulation. It's not the real world at all. The real world is totally different. It's ugly. It's horrible. Humans are enslaved in the real universe, but we're given this imagination, this videotape, so we think we're living in a real universe of prosperity and love and light. Nope, we're enslaved by machines. Well, is that possible? Personally, I think no. But you can't rule it out so quickly because our simulations are getting better and better. But look at it this way. What would it take to simulate the weather? Or even a piece of the weather? It turns out that no computer on the earth is powerful enough to follow every atom, every molecule in a thunderstorm, in a piece of the atmosphere of the earth. So what is the smallest object that can simulate the weather? It is the weather itself. So in other words, computers cannot simulate the weather. Only the weather itself can simulate itself That's how complex the weather is. And remember, we're talking about Newtonian atoms. Once atoms become quantum mechanical, then it infinitely complicates the situation because of the uncertainty principle. Even things that are highly uncertain can happen because of the uncertainty principle. So in other words, with quantum uncertainty, it becomes even more difficult to simulate the weather. And so even though some people think that the universe might be an imagination, it might be a figment of somebody's imagination, it might be nothing but a virtual reality show, I personally don't believe it. I think the universe you live in is the real universe. And on a note of optimism, we should point out that recently a breakthrough was made in Alzheimer's research. Unfortunately, on this program, we've only given you pessimistic stories about Alzheimer's because at the present time, there's no cure. There's no known cure for Alzheimer's, meaning that many of you that hear the sound of my voice will eventually die of Alzheimer's disease. It is the disease of the century, and it's a horrible way to go. My mother died of Alzheimer's disease, and it's just heartbreaking to see someone lose their very soul because their brain is degenerating. Well, the breakthrough was made recently in understanding exactly how the process is initiated. Amyloid protein, beta amyloid protein, builds up in the brain, gums up things, and now we found the tau proteins, and now, recently scientists announced that they've been able to mechanize the mechanism. They've been able to isolate the mechanism itself at the molecular level, which is responsible for gumming up the tau proteins and then the beta proteins. Now, these scientists were careful to say this is not a cure, but it is a breakthrough because now we have a target to focus on to create new drugs, new therapies, new experiments that go to the very beginning of Alzheimer's disease. So in other words, even though this is not a cure, it does seem to work in animals, and there's hope that it will also work in humans as well, as we begin to target the very mechanism responsible for the creation of Alzheimer's.